to communicate to different devices. If I want to communicate, like there one PC is there and PC2, they both wants to communicate, then the IP is required for every device. Like IP address is required in a network. If they both wants to communicate within a network means subnet is same. I have taken here and PC1 and PC2 both are in within a network. There is not a required any L3 device. If I want to communicate different network, then I need a one router. Now I am not taking any router, but see, now coming to picture here, what is the requirement for the IP addresses? What is the requirement for the IP addresses? See, machines won't understand. Wait, give me a second. Machines won't understand the IP address concept. Okay, whichever we have given the IP address, it's a decimal. Okay, they understand only like 0, 0 or 1, 1 likewise only. Understood? Zeros or ones. Machines will understand binary language. They won't understand like any. It's binary in the sense machine language. They'll understand only this thing. But if I want to convert binary to this hexadecimal to binary, we have a IP address concept here. That is we're discussing here. The requirement of IP address. What is the requirement? If you want to communicate two different devices or two different locations, wherever if I want to go through here, we have like a private IP, public IP concept. Those are everything is there. We'll discuss one by one, step by step. Okay, the requirement for IP addresses for these. Any doubts? Guys?
No.
Fine. Just go through the concept. Actually, IP address is a logical address. It is a network layer. It will be work in network layer. Okay. IP address concept is a logical address. It will work in layer 3. And IP address given to every device in the network and is used to identify the device within the network. We discussed it within a network or two different network. We required a IP addresses to communicate the between a device, between a routers. IP address is given to every device. We should have to give the every device. Then only we those devices are in our network or not. We should have to give the IP addresses like host, whichever host, like end user is a PC, and server, whichever server. We should have to give a IP address for particular. It is a unique identifier likewise. With the IP addresses only we can communicate to each other. If IP address concept is that not there means we could not. And here we have like two types of IP addressing: IPv4, IPv4 version 4, Internet Protocol version 4, and IPv6. The IPv4 we have a limited IP addresses, so we have a concept like IPv6. Here we have only 32 bits lakhs of IP addresses. but in this we have a 128 bits. 128 bits. Okay, that is the reason we have a if limited IP addresses. Nowadays we are using both IPv4 also, IPv6 also, like Geo phones. They are started to using IPv6 also. Who will provide the IP addresses? So, INA will provide the IP addresses. Internet Assigned Number Authority. Who will provide to us IP addresses? INA will provide to us. Like public IPs, Internet Assigned Number Authority will provide. And we have public IPs and private IPs. Like here, private IPs are using for the local area network. It is a free of cost. And but now move to the public IP address. It will be routable. We should have to take from INA. Okay, we should have to take from INA, but these are the free of cost, like 192 series. Sorry, 192.168.0.02 and 255, 255, 255.0. I'll give that, and 172.172.16 dot. It's starting from here, and 0.02. We have 172.31 range and 255.255. This range up to will use as a free of cost, no need to pay anyone. And one more range is 10 dot series. 10 dot pool, we have a full of pool. 10.0.02 and 255.255.255. Full range we have free. Okay, again we'll discuss the public IP address also. I'm giving the notes. The requirement IP addresses likewise, and two types of IP addresses goes like IPv4 and IPv6. The example of likewise. Have one more IPv6 also range. The two types, right? IPv4, there we have 4 octets and 8 bit per octet and 32 bits, and it's a decimal number. It will be look likewise, and IPv6 it will be 8 octets. Like see, like for IPv4, take this is one octet and second octet and third octet and fourth octet. Okay, it will be look like in this octet, it will be in one octet we have like decimal numbers 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. It is the last octet, and there are assumed like 1, 2, 3, 4, 5, 6, 7 8, and 1 in the sense like 0 will call it as a 0 power 1, like we'll call it as a, it will be 0, and if 1 is there, it will bit is on. If it is 0, in the sense the value will be 0. If bit is on means 1. Okay, we'll take here 1 in the sense it is on. Likewise, understood. In each octet we have range from 0 to 255. If all bits on, in the sense the value is 255. How it came the 255 value? In the sense, see, makes sense. Here bit is on 1, on this is 1. Calculate as a 2 power 0 and 1. If bit is 0 means 2 power 1. Likewise, 2 power 2. Bit is on 2 power 3. 2 power 4. Bit is here on. That is the reason taking 5 and 2 power 6. 2 power 7. If bit is 0, bit is 0 in the sense the value is 0, like 0 0 0 0, all are zeros. The value equals to 0 only. Okay, if bit is on means 1. Okay, the value is here 1, and 2 power 1 is like value is 2, and 2 power 2 value is like 4, and 2 power 3 the value is like 8, and 2 power 4 the value become 16, the value become 2 power 5 the value become 32, the 2 power 6 the value become 64, and 2 power 7 128. Good. And one more also is there, that is 2 power 8
256.
the bit, the 1 2 3 4 5 6 7 8, the values up to here are close because we have a 8 bits only. 8 in one octet we have a per octet 8 bits only. That is the reason I have taken this much only. Okay, now you can take like 2 power 8 in the sense 256. 256. Here the 256 value is not there in our network. That is the reason. Up to here, any questions?
No.
Oh, all good.
Good. Here in IPv4, the concept is, this one is IPv4 concept. Okay. It is 32-bit address and divided into 4 octets. 4 octets, 1 2 3 4. Now it is decimal number only, but now move to the hexadecimal. It will be 8 octets, 1 2 3 4 5 6 7, 1 3 more is there, like here 4 more is there, sorry. Like one more and one more, one more, one more. These are 8 octets and 16-bit per octet. Here we have only 8 bits, but in IPv6 we have a 16 bits and the bits up to 168. Here we have 8 plus 8 plus 8 plus 8 is equals to 32. But in this IPv4, we have like 16 here and 16, 16, 16, 16. That value will be 128. And it is formed like hexadecimal. The form of IPv4 format is like decimal, but hexadecimal format is there. IPv6 in this is hexadecimal, like 0, 1, 2, 3, 4, 2, 3, 4, 5, 6, up to 3, 1, 0. It will be start from 0, 0, 1, dash, 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 9, up to 9. Okay. Then after 9, the form like A. After then B, it will be more B, C, D, E. Like this one, 10 value is 10. Because in hexadecimal will take it as a values up to 9 only, because of 10 means 1 here is coming and 0 is there. That is the reason we'll take as A, then B, then 11, then 12, 13, 14 and 15, up to 15 only, F only. 10, 11, 12, 13, 14, 15. Okay, good. It is formed like hexadecimal. The format, the IPv6 IP address look like 0, 0, 2001 / 000 and 130F000 09C0. Likewise, we can combine 00 make us like / value, this kind of value. Here, you can check. This is IPv6 format. Up to here, any doubts? IPv6. And each and every octet, like we have a zeros and ones. Okay, just now we discussed zeros and ones. Up to value can be 255. Each and every octet minimum value can be 0, maximum value can be 255, not up to 256. That rule 1 and rule 2 and rule 3 is like IPv4 divided into 5 different classes, and we have a different classes in IP addresses. Class A, class B, class C. These all are the ranges. These all are the ranges. Class A, class B, class C. We have a different ranges of IP addresses. And in this range, we'll use like class A, class B, class C only. Up to class C only we can usable. Class D is for the multicasting, and class E is the future use, but actually wastage only, because nowadays we are not using all machines, all OS operating systems in now the world will understand only class A, class B, class C. So we can't say it wasted. means up to class A, class B, class C only the machines are understanding. Class E, they won't understand because they maybe think like future will use these ranges. Okay, no, those are the wastage only. Now move to the class A. The class A range is 1 to 126. The 127 IP range is reserved for loop back purpose. If you can also check you in your NIC network interface card, if that is the faulty, then just ping here one of IP address like whenever just go to your command prompt and ping 127 in any range like 1.1.1.1. If it is pinging, then your network interface card is perfectly working, otherwise it is not working. That range is reserved for the checking purpose for loop back. And we have like in class A range like we have the value will be like these are the network bits and host bits, and we'll discuss now. And the range will be subnet mask will be look like 255.0.0.0, and the value should be likewise 2 to the power of 24 up to this many IP addresses we have in the class A range, and class B range starting from 128 to 191, and both are the network, 2 are the network bits and 2 are the host bits. And what is a network bit? Actually, network bit in the sense it will be using for the giving the range in between the IP addresses we have will assign the network bit. Actually we are not assigning means whenever we are advertising prefixes in OSPF, BGP, EIGRP, we are advertising like network bit only. It will be look like 192.168.1.0. It will be look like, okay, whenever you are advertising the prefixes in OSPF or EIGRP or RIP protocol or BGP protocol, you will advertise likewise only. It's a network bit. And one more, we have a 255.255.255, the last range of IP address. It's a broadcast IP address. These two IP addresses will not assign to end host, end users. Whichever network bit is there will not assign our end user, end host. Will advertise that prefix in routers only. Will not assign that prefix even though in router also. Will this network bits not for the assigning purpose. For those are the advertising purpose. And class C range is 192.192.0.0.2 and 223.0.00 up to here. And in class C we have like IP addresses 256, 2 to the power of 0, and the subnet mask is like 255.255.255.0. And these are the multicast purpose. We have like in OSPF multicast IP addresses like 224.0.0.5 and 224.0.0.6 for multicasting. 1 to it will be what is the unicast, what is the multicast, and what is the broadcast? Anyone can answer it.
Unicast is 1 to 1
Okay.
and
Multicast is from one to many transition, and broadcast is like total networking one to many.
Okay, good. See. Here the multicast IP address is for one to many, one to group of. But broadcast in the sense the network, it is a last of IP address. The broadcast, the range whichever we have in that range, it will be advertised to all the users. These all are the multicast, unicast, and broadcast and network IP addresses. Any doubts up to here?
All good, sir.
Fine.
Alim, can you say like why 0000? Why it doesn't use? Like, can you tell it again? I'm sorry.
Fine. No issue.
Like from starting, I had like small dot like that one. 000. Why it like default? Why it used for default gateway and why it doesn't use for like everything? Like 255 is like broadcast. I understood like everything, but 000 is a default gateway. Why it is used?
Okay.
And why doesn't use for everything?
Fine. What is the network starting from IP address? Starting IP address is 0.0.0.0, and it will be end to 255.255.255.255. This many IP addresses we have actually. It will be starting from like 0.0.0.1 and 0.0.0.2. Likewise, it will be start 0.0.0.3. These all are the some uses purpose, but these all are the public IP addresses we should have to buy from INA. Okay, the 0.0.0.0 is why it is a default IP address. Why it is a default IP address? Because whenever you don't know where is your destination. Okay, you don't know your destination IP address. Okay, that time simply will tell us your destination, like wherever you will go, whichever IP address, like 10 dot IP address, 10.1.1.1 and 20 dot, it will be the destination. Whenever the destination unknown, it will be considered as a where it will be considered as okay, this is my destination. It will forward the packets. Likewise, it will forward the packets to all of the IP addresses. Broadcast in the sense from in this range, it will be broadcast. From in this range, we have IP addresses, like all the IP addresses from in this range only. You can say 1.126.2 255 up to 255. In this range, it will be broadcast information. I hope you got the answer.
Like 0.0, like it gonna send to whole everything, like
Yes,
whatever it has, like.
yes.
But like
In between,
broadcast
whichever
is
IP address.
whatever it has. That's the only difference.
Yes,
In the only range, it has like range because 255.255 dot like
up to this range.
1.1 means after class B, after class B network, it gonna send the message. And if you go with the default gateway, it will go for like class A, class B, class C, and class D, everything.
Yes, it will be
All right.
default gateway in the sense. But
Yeah.
you think about it, class D and class E both are for we are not using both. These are assigned for some different purpose, but we are using like class A, B, and C. Understood? We'll use
Yeah.
class A, class B, class C only for routing purpose and whatever routing or private IP, public IP range we have in this only. The class D is assigned for the multicast IP addresses only for particular groups. Like you can say like OSPF are having one range, like right 225.0.0 sorry 224.0.0.4 for multicast IP address and 224.0.0.6 you can take as an example for multicast IP addresses. For the what they will do, the whichever in that group OSPF in that area, it will be sent multicast the information. In depth, we will get the whenever we discuss OSPF concept, that time we will get in depth knowledge on that. Good, all good. Are any questions?
It's good, Alex. Thank you.
Welcome. See, in fourth point, we discuss what we discuss. First octet of IP addresses always define the classes, and first octet like 10.0 that first octet of network bits like this, it will be look likewise. Okay, class A range it will be look like, and class B range look like 128 from starting, and class C range is 192 from starting range. It will look like that. Just first, whenever you are seeing, if someone asks to you which range of IP address, just look first octet, this octet, and it's a class A range. The slash value is like 24, and sorry, the slash value is like 8. Understood. Apart from that, here we have a host bits. Those are 24 bits. Those are the 24 bits for the this many IP addresses. 2 power, you can 2 power, just give this 2 power 24, then you have a this many IP addresses in this range. Understood. And here we have only 2 power 24. That is the reason we have a 2 power 8. That is the reason we have a this the 2 power 8 value is 256. This many range we have, this many IP addresses, valid host IP addresses we have. This is the host portion, this is the network portion. Fine. We can only use class A, class B, class C, and class D ranges. Class E is different. We discussed. Just write this content. And move forward. Each and every class having a unique subnet mask, like class A, class B, we discussed. Every and each and every class having unique subnet mask. Like this is a class A range, class B range, and class C range. We have like 255.255.255.0. To create a network ID should be always same, and host ID should be always different. Like if I am creating a one network, I am creating a one network like, so to create a network ID should be always same, and host ID should be always different. Like if I am using here one range of IP addresses, this is the switch is connected to which is connected, and here we have multiple devices. Like you can assume here we have multiple devices, they all are connected in within a network. That time I am giving the IP address for this like 1 dot it's like 0 is a network bit, whichever here I am using as a slash value 24, and so I cannot assign that network bit to the end host. So I'm taking as a 1. Okay. And 1 also we cannot use like it's path. And here I cannot assign the same IP address like 1.1. I should have to assign 1.2. I should have to assign 1.3. Okay. But for this PC, the network ID should be the same. All the PCs having network ID should be always same. But here host bit only changing. Host bit is like last bit. The network bit like here we have network bit. This is a network bit. This one is network bit, and this one is network bit, and this one is a host bit. Only host bit is changing in every device, but network should be same. The range is same. If that range is different, then we need a routing protocol. We need a L3 device. Understood? They won't communicate within a network. Sorry, they won't communicate two different networks. The network bit up to here only. These all are network bits. If that class B, it means if 128 is there, the range 128.1 dot, then these all are the network, again host bits. These are the host bits. And in network bit, starting from 192.168.1212, and it will be moved up to 1.250.
255.
255. We cannot use 255 again. The 255 value is for the broadcast up to 254 only. These all are the valid host IP addresses. These all are the valid host IP addresses. Understood? Here, whichever network is there, -2. Always -2. It means one is network part and one is broadcast. The range will start from like, understood guys?
Yes, sir.
The range is start from 192.168 1.12, and the range valid host IP range will be end with up to 1.254 only. 255 again the broadcast IP address. We cannot assign the broadcast IP address. And how to define IP address, like we cannot assign like our network like starting from 0 also. We should have to assign the IP address like just to go to your command prompt, give this IP address like starting from 0. You cannot assign this IP address also. 254 also you cannot assign. And if you want to assign the IP address like 10.0.0, it's also network bit only. You cannot assign this IP address also, and you cannot assign the 127 series also. We cannot assign this IP address ranges at our end host. And we discussed maximum number of IP addresses at class C, like it will be starting from 0 up to
256.
255 only, because 256
The broadcast one.
the broadcast 255 also broadcast only. In between maximum, it's I'm saying like the maximum number of IP addresses The maximum addresses in one network of any class like 192, 168, 1.02 and 255 only. It will be vary on different, not any. It will be vary on class A, class B, class C. This is a class A, and class B for the different range, class C for the different range. We discussed it. And class A range is like 256, but always do the minus, because 2 to the power of 8 we cannot take as the IP address. And the range is from here, class B. And we have like private IP and public IP concept. Guys, up to here, any doubts?
Yeah. Okay.
Good. After then, these all are the IP addressing concept, and then we have subnetting concept. These all are the IP addressing concept. Finished. Up to here, okay? Fine. What is the subnetting actually? The concept of subnetting. Subnetting involves dividing a large IP network into smaller, more manageable subnetworks and optimizing IP addresses allocations. See, the subnetting concept, we have our requirement, like we have a different VLANs here. Take it as a one switch, and one more access switch, and one more access switch. And here the access switch, these all are in the same network only. The range is like 24. Here my requirement is like this is the one network. Here I'm giving as a one subnet. Here I needed 20 host users, and I needed 20 host here. I needed 20 host here. Okay, but I have the IP address like VLSM, variable length subnet mask, and we have fixed length subnet mask. Here we have VLSM and FLSM, variable length subnet mask and fixed length subnet mask. See, in that we have like here the requirement is 20 hosts are there. I need a one subnet for this host. 20 hosts are there in this VLAN, and in this VLAN we have a like 20 users, and here we have a 20 users. So I have only one range of IP address, 192.168. and 1.0. This range I have. So in this range, how many hosts I have? Up to 254. I should have to assign for the here 20, here 20, here 20. Though, so we have a fixed length subnet mask. If in VLSM, like you can assume like if here one router is there, so one device is also same local area network only. One switch is there, access switch, and this access switch, some end users are connected. There I need access switches are connected. For this access switch, I need like 10 users, 10 IP addresses required. Here I need 30 IP addresses. Here I need, it will be variable type. Okay. Here I have 40 users. Okay, for in this VLAN. So we have a concept like variable length subnet mask. Understood? Up to here in doubts, what we'll do tomorrow, we'll go through this concept. If I am starting this concept, means it will take again one more class. Okay, the process, how it will be happen, everything, the calculation also is there. That is the reason what we'll do. Today we'll bind up, tomorrow we'll continue with this topic.
Okay.
Go through subnet concept, go through it for your reference, and IP address concept also. Fine.
Chalo.
Yep, I got it.